Hello and welcome back to lesson 12, basic trigonometric identities. So this will be the last of lesson 12, product sum identities. Let's start. The product sum identities are derived from sum and difference identities, and in fact this is quite familiar already. These are parts or terms found in the sum and difference identities. So what is the purpose of the product sum identities? So product sum identities are used to simplify expressions containing products. Okay, and if for the purpose, if you we want to have a sum instead of the product, okay, so we're going to use the product sum identities. So if we have cos A, cos B, so we have two angles here, A and B. So for cos A, cos B, we have 1/2. Okay, so everything has a 1/2 here in this side. So we have 1/2 the quantity of cos A plus B plus cos A minus B. It's cos A and cos B. Now, if it's sine A, sine B, okay, so it's still 1/2 times the cos A of A minus B, so it becomes minus here, minus cos A plus B, so it becomes plus here. Okay, so to remember, for us to easily remember the product sum, for cos cos, okay, cos cos and sin sin or sin sin, so the answer for cos cos is just cos, okay, plus cos minus. For sin sin, it's still cos and cos, so cos minus, however, it's minus cos plus. Okay, so that's for cos cos and sin sin. So take note, for cos cos and sin sin, the result has cosines. Okay, if it's the same, so the same factors, so the answer is cosine. So the resulting identity is cosine. Now for sin cos and cos sin, okay, sin cos and cos sin, this is sin cos and cos sin, the result will always be sin sin or sine, then we have sine and then the operations. Okay, so for sine A and cos B, we have 1/2 of the quantity of sine A plus B plus sine A minus B. If it's cos A sine B, so the first angle is cos, second angle is sine or has sine, we have 1/2 of sine A plus B minus sine A minus B. Okay, so the difference here is that for sine, it's common here, sine A plus B is common in both sin cos and cos sin. So, and also sine A minus B is still the same. So the only thing that changed is the signs, or there are the signs. So we have sin plus, okay, it's plus if sin cos. If it's sin cos. If it's for cos sin, it's sin minus sin. Okay, so that's how we are going to remember our product sum and product sum identities. Let's try to erase everything. Okay, so for cos cos, we have cos cos, sin sin, we have cos cos, still cos cos, but the signs are not the same, they are reversed. Okay, so if it's cos cos, plus will be the first one, it's plus plus minus. For sin sin, it's minus minus plus. For sin cos, it's sin sin, but it's plus. For cos sin, it's sin sin, but it's minus. Okay, so let's go to the examples. Let's have example number 1. We have cos 5x sin 4x. So we're going to express as sum or difference. So again, the purpose of the product sum is for us to express the product into sum or difference. So we have cos 5x and sin 4x. So it is cos sign, so they are different. So if it's different, the pattern is sin sin. Okay, the resulting pattern is sin sin. Okay, so but since it's cos sign, okay, so if you try to look at if it's cos sign, it's minus. Okay, it's minus. Okay, then it's plus and minus here. It's plus minus minus. So we will use this concept. So we will have cos 5x sine 4x be equal to sine of the first angle 5x plus the second angle 4x minus the sine of the first angle 5x minus the second angle 4x. Okay, however, we do not forget 1/2. Okay, so we will have 1/2 here. So do not forget 1/2. If it's product sum, there is always 1/2 here. Okay, so let's simplify further. So we have 1/2. We have sine of 9x minus sine x. Okay, or we can distribute 1/2. So we will have sine of 9x minus sine of x over 2. So this is our final answer. Okay, so we have already expressed it as a sum and difference. Let's have number 2. Let's have example number 2. So we have 2 sine x sine 3x. So it's sine sine. So if it's sine sine, so we know that the result is cos cos. Why cos cos? Because we have the same function sine sine. So if it's the same, so the result is cos cos. So in this scenario for sine, remember if it's sine, it's negative negative positive. If it's cos cos, it's positive positive negative. This for cos cos. Okay, so let's try. So this would be 2. Okay, so we're going to apply the identities for sine x and sine 3x. So we will have 1/2 times sine. So since it's sine x, so sine 3x, we have cos. Okay, so cos of the first angle minus the second angle, then we have minus cos of the first angle plus the second angle, close parenthesis. Okay, so let's try to simplify. So we have 2 times 1/2, so cancel out, so we will only have cos. Okay, so x minus 3x is negative 2x minus cos 4x. Okay, but take note, if we have a negative cosine in our even odd identities, so we know that the cos of the negative theta is just equal to the cos of the positive theta. So we know that this is equal to cos 2x minus cos 4x. Okay, so that will be our final answer. And that's the end of the lesson and the end of part 5. So thank you for watching. I hope you have learned a lot. See you soon. Bye bye.